All right, the first section we're doing is section 1.6. It is about compound inequalities. What exactly is a compound inequality? Well, you know what a compound sentence is? You know, from your English classes. Two sentences connected by and or. It is the same thing with a compound inequality in math. It's two inequalities separated by and or. Okay, and that's all it is. So what you're going to do, solve one, solve the other, and then you graph both on the same number line, and that gives you your compound solution. Okay, so this first one we are going to minus the 2 to solve. Remember, look at them as two separate. So you get c is less than or equal to 1, and here I minus the 4, so negative c is greater than negative 2. Divide by negative 1. Remember, when you divide by negative, you've got to flip that inequality, so it becomes less than. Negative 2 divided by negative 1 is 2. So you have 1 and 2, less than or equal to 1, and less than 2. Now, because it's and, you want only what is shaded for both. So when you're looking at this one, for your answer, you want only less than or equal to 1. So it looks like that. Your answer would be less than or equal to 1. Okay. Next one, negative n is less than 2 or 2n minus 3 is greater than 5. Solve this one. Divide by negative 1. Remember to flip that inequality. 2 divided by negative 1 is negative 2. On the other side, you add the 3 over and divide by 2, so n is greater than 4. So greater than negative 2 goes like this. Greater than 4 goes like this, or means you have everything that is shaded, so your answer should be this one, and it is n is greater than negative 2. Okay? Alright, let's do some more. For this one, here we add the 1, so you have 2x is less than plus 1 here, that's 0. Divide by 2, you get x is less than 0. Or add the 1 here to get 2, divide by 2, greater than 1. So less than 0 or greater than 1 looks like that, and that's perfectly fine. Okay, this is what you would give for your answer along with the graphical solution. The next one, hopefully you recall this one from Algebra 1. When it is a compound inequality written like this, that is an and statement. Okay, now you can look at it in two different ways. I like to say, okay, if this wasn't here, all right, I just have this, what do I do to solve? I have to add the 2. So what I really would do is, let me erase that, not cross that out, but what I would really do is add 2 to everything. So that's 6 is less than 2x is less than 10 plus 2 is 12. Again, cross this out, just look at 2x is less than 12, divide by 2, so divide everything by 2. 3 is less than x is less than 6. Okay, so that would be the answer. Now, the other way you could look at that is split it up into two inequalities. You have 4 is less than 2x minus 2, and 2x minus 2 is less than 10. So you would solve both of them. Okay, you would end up getting your same answer. Now when you graph 3 is less than x is less than 6, that's my favorite one to graph. Very simple. You have 3, you have 6, both open circles, and x is in between. So I shade in between. Okay. Now, the one difference with problems like, hang on, back to this, with this one, if you happen to have a problem like this where there are variables everywhere, you cannot solve it, say by like dividing everything by 2. You actually do have to write it out. Okay, so you would have a minus 16 is less than or equal to 2 times a minus 4, and 2 times a minus 4 is less than a plus 2. Okay, we can go ahead and solve that. That's 2a minus 8 minus the a and add the 8, you get, sorry, little thing of mine, I always have to rewrite it so my variable's on the left. A is greater than or equal to negative 8. On this side, 2a minus 8 is less than a plus 2. I'm going to minus the a, add the 8, I get a is less than 10. So, well, I guess I could have left it like that. When you look at it, negative a, 8 is less than or equal to a is less than 10. That works just fine. This one is closed, this one is open, variables shaded in between. Okay, now this one over here, sorry, if I cover up the one side and just look at 3h plus 2 is less than 2, I subtract 2. So subtract 2 from everything. That's 12 is less than or equal to 3h is less than 0. Now divide everything by 3. So 4 is less than or equal to h is less than 0. Now if you look at this, 4 and 0, like they really should be flipped around. Or if you look at it as two separate, 4 is less than or equal to h, and h is less than 0, well this is h is greater than or equal to 4. So greater than or equal to 4 looks like this, less than 0 looks like this. We can't be here and here at the same time. That is no solution. Okay, so you really want to be careful with those. Yes, 4, 0, h is in between them, but you've got to look at where they're written. Okay. Now, these next ones, that is the same. That's that one I did up there. So I'm going to go down to here. Write the verbal sentence as an inequality, then solve and graph the solution. So, 5 more than x is less than 8, or 3 is less than x is greater than 5. 5 more than x is less than 8. So 5 more than x plus 5 is less than 8. Or 3 less than x, so x minus 3, is greater than 5. Solve both. Minus the 5, you get x is less than 3. Add the 3, x is greater than 8. Less than 3, greater than 8. That works. And finally, at an auto auction, the lowest bid for an autographed trading card is $20. The highest bid is $54. Write and graph a compound inequality that describes the possible bids. Well, I know my lowest bid is 20, my highest bid is 54, and that bid has to be between there. That's a B. Okay, that's all they're looking for there. Okay, the bid is in between those two. So when we graph that, 20 and 54, both closed, because you actually had those bids, you can include them and line in between. Alright, so that's it. You now have a worksheet to do in your packet. Go ahead, pull that worksheet out and work on that.